Now, coming to tonight's session, please allow me to welcome Sandeep Gurraj, the moderator of the session. Sandeep is currently the Senior Product Manager of Customer Service Product at Pegasystems. Over the last 17 years, he has worked on successful assignments, both internal and customer-facing, for different products at Pegasystems. He is a collaborative, organized, and communicative team member, along with experience of leading product development teams. He aspires to be a product leader while continuing to learn, mentor, and grow as a part of his personal backlog. Sandeep is also an alumni of the Institute, pursuing the EMBA program in product leadership. Great to have you here with us, Sandeep. Handing the session over to you now.
Well, thank you. Thank you very much, Shama, for that introduction. Greetings, everybody. I was seeing the chat there. There are a few people in Nigeria. Good afternoon, good morning, wherever you are, and good evening, of course. Firstly, I welcome you all, of course, to this edition of Product Leadership Festival. And I am personally happy to host this, we call it like first day, first show keynote once again, probably twice now in successive editions of this Product Leadership Festival. So over the next 10 days, as Shama explained, we have got some amazing array of speakers from around the world. Do not miss out on any of them. Please do log in and tune in if you can, or at least watch those recordings if the time permits, as and when you want to refer them. As a product manager, my first responsibility is to be able to understand the customer well, the needs of the customer well. So before I talk about today's topic and introduce the speaker, I want to get to know all of you a little bit. I'm not going to ask you a lot of introductions as such. We don't have time for that, unfortunately. All I want you to do is please participate in a short poll, a simple multiple choice questions. I think Shama will host the somebody will put up the poll shortly.
The poll is live, Sandeep.
Yeah, there you have the first question, first of the three questions as such. So you could.
And a quick mention, I'm sorry to interrupt you, Sandeep, but for the viewers on LinkedIn, YouTube, Twitter, and Facebook, please click on the Slido link in the comment section to take the same poll. The link will take you directly to the questions. Go on, Sandeep.
Thank you. Thank you. No worries. So this is just for us to get to know you all a little bit, and also help the speaker as well to cater to the audience if needed. Now, have you heard of Google's AlphaGo program? I was doing a little bit of research about this topic for today, and I came across this AlphaGo program. What surprised me was the program itself was, about automating, like mastering the ancient Chinese board game of in a matter of few days. Traditionally, it was believed that this game is something that only humans could excel, only because it requires abstract thinking and human intuition, what could be the best move ahead. But through machine learning, AlphaGo was able to recognize patterns and determine the next best moves on its own. By forming its own strategies, it also went on to defeat some of the world's best human players over the years. We all, when I was a child, I used to hear about chess from the being played online, and the computer playing chess with the greats of the time. But seems like these days every other game is getting automated. Every other game is on the internet, using artificial intelligence and everything else. So that brings out a good thought, in terms of the intelligence demonstrated by these machines, we commonly known as artificial intelligence or AI, in simple words, is this nothing but simulation of natural intelligence in machines that are programmed, I would say, to learn and mimic the actions of what we as humans would do, so that over the years they can perform tasks and replace us. Well, I meant replace us, yes. Organizations around the world are using these AI-powered machines or solutions to maximize the output of their most valuable assets, which are nothing but people, we people. Most of us here, are probably aware of how by automating, previously time-consuming and largely manual tasks, employees can refocus on higher value work. A combination of automation, AI, and data analytics are allowing companies to realize the benefits of intelligent automation. Sounds scary, right? Doesn't it? That kind of brings up, to the topic of the day. But moving towards that intelligent operations in the future requires a fundamental shift in the way the businesses strategize and some powerful new capabilities. Some of the questions that I at least have heard is, do you have the right talent to get into the future, or can you get to the right data uh, to drive or to take decisions in for real transformation, as they say. Now, that is the topic of today's session: mapping out a trip to a digital and intelligent future. I'm excited to introduce our speaker for today, Anirban Nandi. Let me give a quick intro about him before I say hello to him. Hello, Anirban. Um, Anirban is a head of analytics at Rakuten India. He's probably like a pioneer in this area of data sciences, business analytics over the last 15 years, spanning across multiple verticals, and more importantly, building analytics teams from the scratch. He, of course, has a master's in economics from our country's prestigious JNU, some amazing list of alumni, even including the Nobel laureates as well. He started his career at Target and spent there some 8 years working on developing in-house products like customer personalization, recommendation systems, and search engine classifiers. Anirban then became one of the founding members of Data Labs and spent close to 5 years building a team of about 100 members working on different analytics solutions. Currently associated with Rakuten India as the head of business analytics, developing analytics solution for Rakuten's global ecosystem across different domains such as commerce, fintech, and telecommunication, to name a few of them. He's, of course, also instrumental, as I said in the beginning, a very high-performing team comprising of data scientists, data engineers, and even product managers in his Bangalore office. Of course, on the personal side, Anirban loves sports and is a big follower of soccer and football. If you ask him what are his favorite teams, he would probably say Argentina and Manchester United. So that brings that's the time for welcoming Anirban. Hello and welcome. Hope you're having a great day.
Hey Sandeep, yes, I'm having an okay day. I'm a little bit under the weather, so apologies in advance if I'm coughing while I'm speaking. But I'll try to reduce my cough and keep it to a bare minimum as much as possible.
No worries. I was just telling the same thing a few hours before to one of my colleagues as well, that the weather is not so very good in Bangalore here. But I just had a question on the last point that I mentioned about your introduction. I've heard of, probably a lot of others have also heard, Paul the octopus, Achilles the cat, predicting the outcome of a soccer match. Not sure how those animals did that and did it so well, at the end of the day. But I'm eager to know if you ever had a chance to build or, are aware of at least some of them, any algorithm, kind of AI powered algorithm to predict who would win the next soccer World Cup?
It's a very funny story, Sandeep. I was extremely intrigued because as a child, I had played a lot of sports. And when I was doing my master's in JNU and got visibility into the power of AI for the very first time, I was pretty intrigued to have a career in sports analytics or sports data sciences, right? Unfortunately, it never turned out that way. So I'm not a subject matter expert. I know about a lot of other industries outside of sport. But the examples that you spoke about are simple probabilistic models. Okay, it's a 50-50 chance. Sometimes they get lucky, sometimes they do not. But currently, IPL is one place where there is a lot of analytics and data sciences, which is getting powered behind teams and teams' performance. Not so much on predicting whether you'd win or not, but accessing and identifying the different players, their strengths, their weaknesses, and so on and so forth. So a lot of AI is actually getting used to understand the team strengths and weaknesses and how those can play a critical role in you eventually winning or losing. But I haven't heard anything about eventually figuring out whether you are going to be a winner or not.
Okay, one last note before we begin today's topic, Anirban. I mean, I can see a lot of people responding to the simple questionnaire, introductory questionnaire on the polls. Thank you all for posting for your responses. And as Shama said, I request you all to post your questions on the Q&A section of Zoom or on LinkedIn or YouTube. Time permitting, we will have the moderated Q&A towards the end of this session. So Anirban, over to you for a journey into the future.
Sure, thank you. Just give me a minute. Sandeep, can you confirm if you can see my screen?
Yes, I can. Yeah.
Oh, all right. So good morning, afternoon, evening. I'm not sure where all you are based out of, so I'm saying all the three. A warm welcome everyone to the session. I hope that all of you, including your family members, are doing fine during these times. Before I get started, I would like to thank the Institute of Product Leadership for organizing Product Leadership Festival 2021 with the theme of Data Analytics AI and giving me an opportunity to speak in this event. Please note that today's session, I'm presenting more of an individual. I'm not representing my organization in Rakuten, India right now. Today's session is going to talk about, I'm going to cover one of the most emerging fields called Explainable AI. Okay, we have a dedicated time towards the end of the session for Q&A. So we will utilize that as much as possible. Without any further delay, let me get started. So the topic that I've chosen for the first day, first show, like Sandeep said, is mapping out a trip to a digital and intelligent future. Now, a lot of people might think a digital and intelligent future is kind of a black box. And that's what I'm against, okay? A digital and intelligent future has to be known by all of us, okay? And let me start with a simple quote by Michael Basie Johnson. He's one of the inspirational writers in the world. And he says that when people complain of your complexity, they fail to remember that they made fun of your simplicity. At one point of time, situations were so difficult that complexity and simplicity never used to go hand in hand. But times are changing, okay? And specifically in the world of AI. Okay, the topic that I'm going to cover today is a very good example where complexity can be maintained with high levels of simplicity as well. Okay, but before I go further into that topic, let me give you just a brief about the history of AI. Now, we have been hearing the word AI very recently, but the history is pretty long actually. If you look at the history of AI, it was way before 1950s that statistical models were discovered. Okay, 1950s is when machine learning research actually started happening. I am not sure if you guys have heard of this term AI winter. It is not a good season for AI is when we refer to AI winter, because a lot of investments around AI actually got stopped during the AI winter 7, which happened around 1970s. And then towards the later part of 1980s as well. Okay, a lot of people lost belief in the power of AI. Investments stopped, a lot of work was getting stopped. Okay, but fortunately from 2000 onwards, okay, AI has been booming, okay, with supervised ML methods becoming very widespread. Okay, and 2010 onwards, deep learning has become very, very widespread. Now I understand that the audience today is a very mixed group, so I'll not go into the details, but the message that I'm trying to convey here is that AI is not new. AI has been in existence. And specifically from 2010, 2005 onwards, there has been a lot of work which has happened in the field of AI. Okay. Now, what is digitization AI and its influence on us? Now, if you look at it, currently AI is everywhere. You hear augmented reality, virtual reality, automation, artificial intelligence, blockchain. AI has engraved all the fields that we touch in our day-to-day lives. But what has happened is that even with this huge increase in the use of AI, as humans, we sometimes find it difficult to understand and comprehend how AI makes decisions. Okay. And these are the following challenges that we face with AI systems. What we try to understand is that how AI systems make the decisions. Okay. The lack of explainability and trust hampers our ability to fully trust the AI systems. Unclear security, privacy, and ethical regulations are also associated with AI. Okay. And regulating bias with AI systems basis the data that feeds into the AI system is also been a problem. So what we are seeing is that AI as a field, which was always there, has started evolving and growing more and more matured. But as humans, we are still finding it difficult to understand. So what's the answer to this? Okay. Now, before I go into the answer, okay, let me talk about one more thing. Okay. With AI, you always associate the word called accuracy. How good is your model? Okay. How good is the AI predictions? Like Sandeep was talking about an example. Can I actually predict, okay, whether a team is going to win, let's say, the soccer tournament next year or not? Okay. Now, how good is that? Okay. It talks about accuracy. Okay. But let's say I build a model, I build an AI model which says that a certain team will win. Okay. What is important is, can I explain it back to Sandeep or any one of you that why did I predict that this team would win? Okay. And with the evolution of AI, what we have seen is that accuracy has gained more prominence. Okay. And explainability has not gone prominence. Okay. With models, okay, and algorithms getting more and more complex, okay, explainability has taken a downside. Okay. And accuracy has always taken prominence over it. Okay. Now, this is a big problem because as human beings, we are very logical people. Okay. Okay. We understand that, okay, Anirban and his AI models are saying that this particular team would win the soccer tournament. Okay. But can Anirban and his team explain why are they saying that this team would win the soccer tournament? Let's say if you are into the world of betting, okay, today, if I tell you that, okay, my model is 90% accurate, please go ahead and bet on this team XYZ. Okay, although betting is illegal in India, just for the sake of an example, that, okay, this team XYZ would win the tournament. Okay, would we as person or human beings go ahead and blindfoldedly trust Anirban and his team saying that this model is 90% accurate? No. But if I can provide an explainable layer on top of why we are saying this model is 90% accurate, I am pretty sure a lot of you would get convinced and might want to bet. Again, your personal choice about betting. It's just for the sake of an example. So the answer and the point of discussion for today's topic is explainable AI. Okay. Before I go into explainable AI, let me quote something that Sundar Pichai recently said. Okay. And I'm sure everybody know that Sundar Pichai is the CEO of Google. Okay. It's not enough to know if a model works. Okay. We need to know how it works. Okay. And this is where explainable AI plays a very important role. It's not only about just incorporating algorithms, implementing algorithms from the field of AI, but we need to understand how these algorithms work, not just from a mathematical standpoint, but from an implementation standpoint as well, so that people who actually consume the algorithm output can easily comprehend and understand the output. So this brings me to the topic of explainable AI. Okay. And this is where I correlate it back to my topic of making a trip to a digital and an intelligent future. Okay. The digital and intelligent future is a lot to do with explainable AI. Okay. And the reason why I say this is because we are talking about organizations here. Okay. You are talking about entities. Okay. And most of the organization and entities all over the world are people driven. Okay. These are at the back, they are all driven by people and processes, right? Now, if they're driven by people and processes, okay, and if you want to convert them into data driven, okay, explainable AI plays a very important role. Okay. So what is explainable AI? Explainable AI is actually one of the emerging fields in machine learning that aims to address how black box decisions of AI systems are made. It basically converts black box into white box. If you look at the technical definitions of explainable AI, okay, and in short, it's actually called XAI, okay. If you look at the technical definition of explainable AI, it basically, the term tends to refer to the movement, initiative, efforts made in response to AI transparency. AI transparency is the important word, and trust concerns more than to a formal technical concept. Okay. DARPA, one of the major institutes of the world, has done a lot of work around explainable AI. Okay. And it says that XAI aims to produce more explainable models while maintaining high level of performance. Okay. So which basically goes back to one of the slides that I was showing previously, that you do not have to compromise on accuracy while maintaining your explainability. A decade back, I would definitely say that you would have to compromise on accuracy, okay, to make sure that your models or your algorithms are more explainable. But with all the work that is happening around explainable AI recently, you don't have to compromise, and both of them can work hand in hand. So why do we have to, why do we need to explain? Okay. And there are 4 important reasons why any AI algorithm needs to explain. Okay. We have to explain to justify. Okay. So that it becomes auditable and provable in every specific way. Okay. And it is fair and ethical as well. And all of this, if it's auditable, provable, fair, ethical, it helps build trust. Okay. So that's called explain to justify. Then we also have to explain to control. Okay. If we incorporate XAI, we give greater visibility over unknown vulnerabilities and flaws, okay, thereby reducing or correcting for errors. Therefore, we can control. Obviously, if we know the solutions, we can explain to improve as well. If it's not a black box algorithm, and if we can convert some of our black box algorithms into white box, okay, we would know how we can make the outputs more better. Okay, we can make it more smarter. We can improve on accuracy, so on and so forth. Okay. And finally, we have to explain to discover as well. There are a lot of new facts that we would not know. There would be a lot of biases which would have gone into your AI algorithms. Okay. And if we know with explainable AI, we would be able to discover them and course correct as well. Now, if you look at, this is from Google Search Trends, if you look at explainable AI as a concept, okay, and within explainable AI, there's one subconcept called interpretable machine learning. Okay, explainable AI and the academic publications which are happening around explainable AI has been growing pretty significantly. Okay, from 2005 onwards, and specifically in the last 3 years, you will see a huge rise. Okay, but interpretable machine learning algorithms, okay, which is a subset of explainable AI, if you see the blue line, you'll see a lot of search, because that's where data scientists, data analysts, data engineers, your product managers, okay, software engineers as well are implementing this. Okay, that's why you will see a huge rise in the blue line. Okay, if you look at the search trends, okay, that was the academic publications. If you look at the search trends, it will also follow a very similar pattern, where explainable AI as a concept is definitely growing. Okay, but within that, interpretable machine learning as a concept is going a lot further as well. Okay. Like I was saying, explainable AI is a bigger field. Interpretable machine learning is a smaller field within that. Okay, and it basically talks about interpretable machine learning. Basically talks about 4 different things. Okay, with trust being at the center. The first thing that it talks about is fairness. Okay, are your predictions made without any discriminable bias? So we want unbiased predictions to happen, accountable. Now, let's say if we do some predictions, can we really track it back? Okay, so can I hold myself and my model algorithms accountable for any decision making that they are doing? And eventually, transparency, giving complete transparency to the business, to all human beings, that why certain predictions are made. Okay, let me give you a simple example here. Let's say I go to a bank, okay, and I apply for a home loan, and my home loan gets rejected. Okay, obviously there are predictions which are happening why they would say that your home loans are getting rejected as well in the fintech industry, right? Now, but with explainable AI, the bank can actually explain to the customer that these are certain parameters or these are certain reasons why your home loan might have gotten rejected. Okay, again, just as a concept, okay, don't take it in the real terms, but these are the models that are getting powered to for the organizations on a day-to-day basis. Now, if you look at the taxonomy of explainable AI and specifically interpretable machine learning, because I did not want to cover explainable AI because that's a very, very broad field. Okay. And interpretable machine learning is more focused, and a lot of you can correlate because you guys might be working on machine learning as a concept within AI. Okay. Now, there are different taxonomies of interpretable machine learning. The first one is called scope related, which is global versus local. Okay. Global basically talks about is the interpretable machine learning or the explainability that they can provide an interpretable machine learning. Can it be explained on the entire set of data, or can it be done only for a localized set of data? Both has its own uses. Okay. But again, there are different use cases where sometimes you'll need to provide explanations at the global level, and sometimes you'll need to provide explanations at the local level as well. Okay. Then we would have some things around application related. Certain explanations can only be provided for certain models, okay, or certain algorithms, which is called model specific. Model agnostic basically means that irrespective of the algorithms that you're using in the interpretable machine learning field, okay, the explainable AI or the interpretable machine learning can help you understand them. Okay. And pre-intrinsic post-hoc are basically concepts that whether you can provide explanation prior to your algorithms or the models being built, during the algorithm building process, or after the algorithm building process. Okay. Most of the applications are post hoc. After the algorithm is built is when you provide the explanations. Okay. From an algorithm standpoint, there are algorithms which talks about how can you provide explanations around features. Can you provide explanations more than features which are around rule-based and counterfactuals? I'll cover all of this, the feature importance, the rule-based and the counterfactuals very briefly, given the wide variety of audience that we have today. Okay, and I'll just introduce you to some of the key terminologies there. Okay. One of the most widely used things is that people think that interpretable machine learning or the explainability bit of machine learning is restricted to tabular data. Unfortunately, it is not, or fortunately, it is not. Okay, it is applicable across everything. Okay, it can work around your tabular data, image data, text data, everything. Okay, there are different algorithms which support the tabular data versus the image data versus the text data. Okay, but it is applicable across everything, all kinds of data. Now, let me give you some of the details and the use cases of the different interpretable machine learning techniques. Now, here, I will keep it at a very broad level because these are specific algorithms, and I just want you to introduce the name of the algorithms to you. Okay. If you are interested to learn more, please do research, or you can reach out to me. I can also provide additional details. Okay. The first one that I wanted to introduce as a concept is called something called SHAP. Okay. Now, this SHAP is a name of an algorithm which fits into the interpretable machine learning world. Okay. What does SHAP stand for? SHAP stands for Shapley Additive Explanation. Okay. If you guys have heard about the famous game theory examples, okay, it is based on the game theory examples, and it is a feature importance based method supporting both local as well as global data. Okay. And it is also model agnostic, which means that SHAP can tell you which features in the model are important, okay, can support one data point in the entire or across all the data points, and whatever algorithms that you use, SHAP can be used on top of it. Okay. Now, let me explain SHAP with an example, very simple example. Okay. Now, here's an example. The chart that you see on the right-hand side below is one of the most critical outputs of a SHAP algorithm. Okay. Now, the data set that I have taken for the example purpose here is a data set which contains a lot of variables like age, sex, type of chest pain experience, resting blood pressure. So it's patient-related data. Okay. And what we are trying to predict is basically whether a person is likely to have a heart condition, okay, heart disease or not. Okay. What we are saying here, and this is basically looking at the right-hand chart, and you don't even have to read any of this. Okay, the right-hand chart in itself can help you determine what is needed or what impacts the probability of you having a heart disease or not. Okay, what we are saying is that if you look at the first variable that we had taken into consideration is the number of major vesicles. Okay, if the number of major vesicles is low, blue on the right hand side, you will see that red means high, blue means low, if you see since blue is on the right hand side, we are saying if the number of major vessels is low, there is a higher probability that you will have heart disease. Okay, and similar with the thalassemia reversible effect as well, that if the number of thalassemia reversible effect is low, you'll have higher heart disease. This chart in itself talks about, first of all, it provides on the, if you look at the chart and if you look at, let me try to annotate. If you look at all this data here, okay, these are basically your features. So it talks about the feature importance. It is rank ordered. So the number of major vessels that we have considered is the most important feature, and the lower important features are right there at the below. Okay, then it also talks about this difference. This difference is very important. Okay, first, oops. Hello.
Yes, Anirban, we can hear you.
For some reason, my system has gotten frozen. Just give me a second. Sorry about this, guys.
No worries.
I am not being able to move anything from my system. I am so sorry about this. Sandeep, do you mind taking away my control or make me an audience and then get me back here as a presenter?
Sure, I can do that.
Yeah, can you try doing that, please? Because I've lost entire complete control of my system. Apologies, guys.
Okay.
We can see you and hear you, Anirban, so you can continue with your learnings. So while I do that.
It's just that my present okay, let me complete the SHAP bit as well. So what we are seeing is that, like I was saying, the features which are at the top are the most important features. So if you build any kind of AI algorithm, okay, the features which will come out of this SHAP plot will basically talk about that these are the most important features. The difference between the red and the blue line, and I wanted to annotate here, and that's where I got stuck, also talks about these features are really, really important. Okay, if you look at the features right at the below, okay, the red and the blue tends to coincide, which basically means that this feature is not being able to differentiate between whether a person has higher probability of having a heart disease versus not. Okay, so these are certain things that a SHAP can help you do. Now I wanted to move on to my next thing. Have you been able to do that?
We are trying that, Anirban. Just give us a moment.
Anirban, can you hear me out?
Yes, I have been able to figure this, I think.
Yeah.
Can you see my screen again?
Sure, we can do that. Yeah.
I've been able to figure it. Okay. There was a problem with the annotation. Okay, so moving on without wasting any time. So SHAP was just one thing, okay, which talks about interpretable machine learning. And this talks about, like I said, it talks about features and the importance of it in AI algorithms. Okay. The next thing that I want to talk about is very famous. I think a lot of us have grown up eating this. Okay. Although this spelling is different, it's called MAGGIE. Okay. It stands for Model Agnostic Global Interpretable Explanations. Okay. Now, what SHAP was able to do is tell you that when you have built an AI algorithm and you have set in a lot of, let's say, 1,000+ features, that these features are the most important in doing your predictions. Okay. What it does not tell you is basically what values of those features are important. Okay, let's say for a very simplistic example, let's say we are saying that, okay, we say that, okay, age is important for a certain prediction. Also, age is kind of a biased variable, but it just is a lot easier to explain, and hence I'm using it. Let's say age is important for predicting whether you do certain activities on the e-commerce website. Okay, let's say we're using age as a feature there. What SHAP will never tell you is that what values of age. I'm pretty sure, and all of you pretty well understand, that age can differ from, let's say, 0 to 70, 0 to 80. It's a broad range, right? Not all values of age will have equal importance in driving this functionality. Okay, or all values of age, maybe there is a certain age band between 20 to 35, maybe, which has higher probability of you performing a certain action on a certain website, right? So that is where MAGGIE comes into the picture, and MAGGIE helps you identify with simple if-then conditions, so that you as an end user or consumer, you understand that, okay, now I know that age is important, but okay, these values of age are also important. Okay, I'll keep the explanation to this because at the back end, it's a pretty complicated algorithm. So if you want to learn more about this, do some research. Very limited research material or academic publications is available on the internet. So you'll have to do a little bit of research around this. Okay. Now, what we did first, we spoke about SHAP. We spoke about features, which features are important. Next, we spoke about MAGGIE as an algorithm. Okay, where we said, okay, now that I know my features, what values of features would be important. The third one is, again, another extremely new field called counterfactual explanations, okay, which says that, okay, I know this feature is important, okay, but let's say, how do I have to convert this feature to make myself move from a non-desired class to a desired class, maybe, or a non-desired outcome to a desired outcome. The example that I was talking about was, let's say, for some reason, my loan got rejected. Okay, SHAP can help me tell you, SHAP can help all of you understand that, okay, why Anirban's loan got rejected. Now, my question to the bank could be, or the financial institution could be, what do I have to change for the loan to get approved? Okay, that is where a counterfactual explanation comes into the picture, and it tells you that, okay, there are certain features that you have to change from certain values to certain values in order for the loan to get approved. Okay, this is where counterfactual explanation comes into the picture. Again, these are only 3 algorithms that I've introduced as a concept to you. Okay, there are multiple use cases, multiple different algorithms in the field of interpretable machine learning and explainable AI. And if you want to learn more, there is limited but enough material available to kickstart this journey. Okay. Now, I don't want to cover this use case in details. Okay, but what I want to talk about is the advantages of interpretability. Okay, so obviously, what we spoke about is that there is a lot of use to use. It will be extremely easy to use if we have interpretability tools or products. Okay, it is extremely customizable and flexible. Okay, and it provides comprehensive capabilities, which means that it can develop output or create outputs which are easy to comprehend by any kind of people. Okay. Now, who can benefit from interpretable tools and products? Obviously, data scientists, auditors, business leaders, and researchers. Now, why am I suddenly talking about tools and products? Okay. What I had spoken about in the past is explainable AI, interpretable machine learning, okay, and the different algorithms. Okay. But we need to do this at scale. It is very important that all of these algorithms are converted into scalable products so that different organizations can smoothly use it. Okay. Today, as an auditor, it is very difficult for somebody to actually use the raw algorithms in itself, like SHAP, MAGGIE, counterfactuals. Okay. So that's why using explainable AI, interpretable machine learning, the algorithms which power them, we have to build tools or products which can make life easier for the entire user space. Okay, and that's why it is very important that you understand what you can do. Okay, with, like I've been saying time and time again, with interpretability tools and products, you can explore your data and model performance at your ease. Okay, you can explore model errors, you can analyze data set statistics distributions. Okay, you can analyze how your model performance changes. Okay, and you can gain model understanding as well. Like I said, global understanding, local understanding. At Rakuten, we are extremely matured. Okay, we have our Rakuten AI team is almost 1,000 plus across 6 different geographies. Okay, and Rakuten is at the center. Rakuten AI is at the center where a lot of business decisions are taken, and that's why we have a lot of tools and products. While I cannot give complete visibility on Rakuten AI tools and products, I've just taken some examples on interpretability tools and products which are available in the market, which is one is around mixed panels anomaly detection. So it's a tool which provides interpretability around anomaly detection. A lot of you might have heard about Tableau. Okay, and Tableau can explain data, and the backend of this is actually explainable AI on interpretable machine learning. Okay, ClearBrain. Okay, again a marketing optimization platform, helps understand the output through interpretable AI. Okay, Fitwell Labs, again an explainable AI platform in itself. Okay, which you can use. Okay, but again, these are examples of tools and products which are available in the market. Okay, and people are talking about developing tools and products and scale backend powered by explainable AI on interpretable machine learning, and front end powered by a simple user interface, so that organizations which were people driven we can help them convert them into data driven. Now, if you expect that we can just work with simple algorithms, it becomes very difficult, and that's why you need these tools or products to work at scale powered by explainable AI. Okay, this is just an example of SHAP. Okay, it's an open source tool in action. Okay, you can see this. You have a specific open source code which is available, but provides a lot of what I have been talking about in the last 30 minutes at the tip of your hands. Okay, this is another one which is called Interpretability. Okay, again an open source tool. Again, these are all open source things which are available for you, and you have to use this in your day-to-day life and build products powered by this. Okay, now so what are some of the common properties of explanations generated by interpretable methods? Okay, obviously, like I said at the very beginning, accuracy is important. We don't want to let go of accuracy, so accuracy still becomes important. Degree of importance, stability, comprehensibility, consistency, novelty, certainty, all of them are very, very important properties that interpretable methods needs to take into consideration. Okay, tips for choosing. What's your first of all, we need to understand this, and I will go reverse. Okay, what is the user's expertise level? Okay, and generally when I talk about this, I intentionally talk about it in the reverse manner. Okay, users expertise level determines which kind of interpretable methods would you choose. Okay, which algorithms, which products, which algorithms powering which products. Okay, in our current organization, we have multiple products on explainable AI, and there are multiple, not all the algorithms provide actually provide the backup for all or power all the XAI products. Okay, for example, for one of our products, it's just SHAP based. For others, it's an ensemble of SHAP, MAGGIE, counterfactuals. Then there's one product where it's only counterfactuals. Okay, depending upon the user's expertise level, you need to make sure that which kind of interpretable methods are being chosen. Okay, time limitation, obviously. Okay, very, very important, and we need to understand the whole logic of the model as well. Okay, behind the certain decisions, because like I've been telling again and again, this is very, very important for organizations and entities to become data driven. Okay, now this is something for your own interest, given that there was so limited material or academic publications available on the internet. A press actually reached out to me and one of my colleagues to write a book around this, and this will come out very, very soon. So if you're interested to learn a lot more about interpretable machine learning models and explainable AI, you can refer to that as well. All right. With that, I will come to the end of my presentation. Thank you again for listening to me. Okay, and we can do 9 minutes of Q&A.
Sure. Thank you. Thank you. I'm just going to moderate here with the questions here. So let me take this first question straight to you. How SaaS companies will deal with the explainable AI? Because the question says because they might lose their copyrights.
It's a very complicated question. Okay. See, software as a service, okay, has a lot of different components. Okay, and explainable AI algorithms, okay, are not copyrighted. Okay, what we are saying is that first of all, you can create your own explainable AI algorithms, okay, and you have to power the SaaS products. Okay, because see, at the end of the day, okay, all the kind of SaaS companies that their product, okay, a lot of them, from my own personal experience, are not getting used to its fullest potential because nobody trusts that output. Okay, it's a black box output. Okay, and what I'm saying is that you power these SaaS products like Tableau. Okay, the example I'm talking about is Tableau. Okay, Tableau provides licenses to all of us for usage, right? So it's a SaaS kind of a product as well. Okay, now they are also using explainable AI. Okay, it does not make sense that they'll lose their copyright because of that. Right? So that is a very good example. So because a lot of decision making becomes unknown, okay, to make it very, very known to people, a lot of SaaS organizations will start. I know for a fact, I have a lot of colleagues of mine who are building SaaS products, okay, and they have started using explainable AI to back their products. It sells a lot more that way.
Okay. The next one, little interesting personally as well when I read the question. So we talk about prediction based on the data from the past experiences. But why is that so? Can we say that for example, the person who's asking the question here gives an example, like a generation gap thinking of the human mind, is same 100 years back. What is it right now, and what would it be next in the 100 years later on? So how can we measure these issues, or how can we track these issues?
Sandeep, let me read the question once because I don't fully comprehend the question. Why prediction always depends on past experiences only? Can we say that gap thinking is same 100 years back and the current situation after? Yeah. So AI as a concept needs to learn from something, right? Okay. So that's why it is always basis past experience. Okay. Now, what is important and where I see I don't agree to this question is that when AI actually builds a kind of a prediction, it does not necessarily look at 100 years back. Okay. It looks at historical performance. Okay. Historical performance could be last 5 minutes as well. Okay. I am pretty sure what you're doing in the last 5 minutes will have an influence on what you're going to do in the next 5 minutes. Okay. There are a lot of fields in machine learning. Okay. Some of them being supervised, unsupervised, but there's a new field in the world of machine learning. It's called federated learning. Okay. Which uses almost like real-time data to do prediction. Okay. So yes, it has to learn from something. Okay, that's the reason why it looks at past, but the definition of past is completely in our hand as of today. Okay, today when me and my team actually builds AI models, we actually think that do we need 3 months data, 6 months data, 1 day's data, 100 years worth of data, okay, to predict for the next, let's say, 2 months, 1 week, whatever it is. Okay, and we use different sets of data to actually see which one comes out to be the most important. And that's why that's also very important. Let's say I'm trying to do a prediction for the next 1 day. Okay, I will have features which are corresponding to 1 day of past, 2 days worth of history, 3 days in the past, 4 days, 10 days, 100 days, 1 year. Okay, and let the model decide which one is more important. Okay, with explainable AI, you will also understand that, okay, maybe the data which was last 7 days is most important for predicting the next 1 day. and not for the last 1 year. I hope that answers your question, because that's the best I could make out from this question right now.
At least it answered me. At least I'm not sure. I hope the person who's asking their question could also respond over the chat sometime. Just moving on to the next question here. How are data segmented, for e-commerce clients and presented over different channel modes or OTT channels as such?
Data segmented for e-commerce clients. Data segmentation is a very, very subjective concept. Okay. See, most of the data in any kind of e-commerce. Okay. And you will hear this if you are associated with e-commerce as an industry, you'll hear this word called clickstream. Okay. Clickstream is the data which most of the e-commerce organizations actually capture. Okay. It tracks all your clicks, okay, within the website. Okay. And this is one of the reasons why big data came into the picture, by the way. Okay. Traditional data houses were being able to accommodate fintech, telecommunication, even retail. Okay. E-commerce came into the picture with not their transaction data, but with their clickstream data. That's where big data got from. People started talking about big data. Okay. Now, data segmentation, it depends on the use case. Okay. Depending upon what use case, what business problem are you trying to solve, the data gets segmented in different cuts. Okay. And then it gets presented. Okay. So there is no one true answer saying that, okay, if for this specific data use case, there could be one data segmentation. For another specific use case, there could be another data segmentation. Okay. And similar for modeling as well. Not every, so we cannot have like a set of data segmentations or features saying that, okay, here's what we have, we need to fit it everywhere. It does not work like that. So that's why you have a concept of data lake. Okay. And then you have smaller databases on top of it, which feeds from the data lakes. Okay. The databases actually serves your specific business cases. The data lake, okay, is for the entire business.
I'll quickly take two more questions here. One, of course, is about you yourself are building up teams and hiring people into this area. What skills and how should somebody acquire skills to build to get into this area of explainable AI and build some awesome products in future?
Not specific to explainable AI, but this is specific to me. You need to have the right attitude. Okay. See, as kids, we were able to learn ABC, right? Okay. You'd learn explainable AI, forget explainable AI. You'd learn AI, data sciences, data engineering, all of it. You need to have the right attitude. Okay. You need to be flexible towards unlearning what you have learned in the past and saying that, okay, there is new opportunities for me to learn. Okay. If you are doing that, you are good enough. Okay. And a lot of focus on Rakuten's AI hiring is hiring people with the right attitude. Okay? So if you are somebody with the right attitude, please reach out to me. Okay. We do have enough trainings, okay, to support you learn these concepts, but you have to ask yourself, are you the person with the right attitude? Can you unlearn what you have learned in the past and learn new things? Okay. Be flexible enough. Okay. Because see, at the end of the day, you will have to unlearn, learn new things and still deliver, which also basically means that you have to push your boundaries, because if it's a new field that you are entering, if it's something that you are coming with your traditional backgrounds, there are a lot of, including Institute of Product Leadership, right? They provide the right set of education from the very beginning to provide all the base that is required from an educational background standpoint. And then you can pretty much jump into this field.
Okay. One last question. I'm sure there is there's a time for that. How through explainability, help organizations that there was no bias in suggesting recommendations or predictions? And if I can add to this question, Anirban, something like you took the example of predicting a disease or a heart attack for somebody. At the same time, how do we? I think one of the things which I see is in how do the people communicate? How does the doctor communicate that to the patient? It's not right to say that the black box told me, that the machine told me so, as such. So I think it's more important on how do we also, or how do users communicate that to the consumers at the end, and that's probably the answer for the question wherein how can you say that there was no bias.
Absolutely. See, there are two levels of bias. Okay, the first reason why explainable AI is required is within an organization itself. Today, let's say I want, and these are biases that have existed in the past. Okay, again, just for the sake of example, so that all of you understand, let's say I'm trying to predict whether a person is going to default on a loan payment. Okay. Or whether, let's say, a person is going to commit a fraud or not. Okay. Now, if we are saying that ethnicity as a feature is a reason for committing fraud, that's a bias. Explainable AI tells you right there, okay, see, you are using ethnicity as a biased feature to predict fraud or commit fraud. Okay, very, very wrong right at the outset, right? So that is the first level where you can remove bias, saying that I cannot use explainability to predict whether somebody will commit a fraud or not. Okay, there has to be other features that I have to look into, okay, to do this, right? Maybe, and there are two reasons why we have used this feature, ethnicity. Maybe the data that I'm using to predict the fraud has a bias towards one ethnicity than the other. So there are two reasons. That's why I said the data could be biased in itself. The data which is going into the predictive model could be biased in itself. First level of detection that happens from explainable AI. The second detection that happens is ethnicity cannot be used. Okay, and that's how a lot of different communications needs to happen. And that's why eventually, Sandeep, to your question, that can the doctor tell the patient that this is the reason? No, only if the variables are completely biased. Like today, if let's say I go for a doctor checkup and I say that, okay, doctor tells me that you have a higher probability of having a heart disease, and he tells me that your number of major vessels are not, you have low number of major vessels in your heart, right? It's a valid reason, it's a valid feature. It is not biased. It's my heart condition which has lower number of major vessels, right? There is no bias in this. Okay, but can he tell this to me that because you are a boy, okay, or because you are a male, you will have a heart condition? No, because I think both male and female, every gender has equal probability of having a heart disease.
Right.
It's a lifestyle that has led to that, right? Not just because I am a male. So that's why after building your algorithms, it's important to look at the explainable AI bit. Okay, make yourself a lot more educated, get a transparent solution, and then understand, and then eventually approve, audit this model, and then it goes into production.
Well, yeah, I mean, and to that factor, actually, like, not just about the lifestyle or the gender. I mean, and I'm sure nobody wants to hear that, okay, because we are in the software industry, you have a high probability of getting a heart attack. I do, of course, realize that, okay, we are a little past over the time for this session, but thank you very much. That was an awesome presentation and an awesome session. I'm sure there were a lot of things to that our audience here are taking away. There are, of course, questions as well, which, as you said, is a very niche area, is a very new area, which needs a further exploration as well. I would like to summarize with a few things that I would take away is why the explainable AI is relevant. To be able to justify the decision and to be able to control the decisioning and improve the algorithm, and of course discovering new facts. And of course, thank you for sharing those timely and relevant quotes. I'm sure I'm going to use that for some of my next sessions as well. Yeah, and as somebody said, thank you for persevering through your cough as well. So a big thanks to all those who joined today's session. Don't forget to tune in tomorrow and through the rest of this week for similarly awesome sessions. Over to you, Shama.
Yes, firstly, thank you, Anirban, for the brilliant and engaging session. The keynote was captivating with some really great insights from your side and your experience in the profession. So we have enjoyed having you with us, Anirban. It's been a complete pleasure. Please accept this certificate of appreciation from the Institute, a small gesture. We're grateful for the time and effort you put to share your thoughts and amazing insights drawn from your experience in the industry. And if you scan the QR code on the certificate, it will take you to a dedicated Hall of Fame page that we have created for you, which will hold the recording of the session. Just give it a few hours for us to upload and you'll have your recording.
Sure.
Thank you, Sandeep, for facilitating this session beautifully with your great insights as well. Thank you for joining us.
Thank you, guys. Have a great evening. Bye-bye. Take care.
Before we go off, I'm sorry, but I request Sandeep to, as we promised before, that we'll be rewarding the best question with the scholarship of $200. So Sandeep, Anirban, either of you, go ahead and pick your best question and we can reward them with the scholarship.
Okay, Anirban, do you have a particular pick?
Sandeep, please go ahead. You're the moderator. Please go ahead.
Sure. I think I felt Vidya Sagar Kumar. Question from Vidya Sagar Kumar.
Perfect. Congratulations, Vidya Sagar Kumar, on winning the T scholarship, and we'll get in touch with you shortly with the reward. Audience, if you found today's keynote useful, take a few seconds to share your feedback, experience, and perspective on the session and inspire others to join the subsequent sessions. Please scan the QR code to share your feedback. Your feedback is critical for us to make improvements for the next round of festival. Folks, one of the main purposes of hosting and conducting the Product Leadership Festival is to build and nurture the product community in this country. There's already a very strong thriving community of 2,000 plus members where a lot of content is being shared by product managers and CXOs, sharing their learnings and insights. Please scan the QR code or click on the link in the chat window, community.productleadersforum.org, to join the community and grow with us.